Over the last 100 years, our planet has seen a remarkable surge in social and economic development. This growth has required a vast amount of metal to support this rise in standard of living and to build society's infrastructure. Metal demand is set to continue to climb due to an increasing global population and with emerging economies transitioning to industrialized and urbanized societies. At the same time, the rate of new major mineral discoveries on land is slowing, and the environmental and social costs to extract what metals have been found is increasing due to lower ore grades and progressively complex land access issues. A cleaner and more economically attractive supply of metals is now of great importance. DeepGreen Resources and Nauru Ocean Resources are looking to meet this challenge and transform how the world sources its essential metals. The opportunity begins 4,000 meters down on the sea floor in the Pacific Ocean's Clarion-Clipperton Zone, situated between Hawaii and Mexico. Here, golf ball to potato-sized nodules are formed as a result of ocean currents bringing together metals in solution that have been eroded over millennia from deposits in the nickel and copper-rich Andes and Rocky Mountains off the west coast of North and South America. The formation of nodules occur in many seafloor locations. However, the Clarion-Clipperton Zone hosts the world's greatest known concentration of high-grade polymetallic nodules. The large size and high-grade nature of this multi-metal deposit is simply no longer being found on land. Integrating offshore oil and gas and maritime technologies, NORI plans to harvest nodules using remote-controlled harvesting vehicles to deftly collect the nodules from the sea floor, so that they can be conveyed to the surface via an air riser lifting system. One of the many attractive environmental advantages to this deposit is that the nodules sit unattached to the sea floor. Unlike many terrestrial mines, there is no requirement for pre-stripping or bearing the economic and environmental costs associated with shaft sinking or drilling and blasting large quantities of waste rock. Mineral extraction on land often results in huge acid-generating waste piles being created that need to be managed in perpetuity. Polymetallic nodule harvesting produces no such waste rock. Once the nodules have been brought up to the production vessel, excess silt that has been transported to the surface with the nodules would then be returned to the lower depths to further reduce the environmental disturbance. Once on surface and on board the trans-shipping vessels, the nodules can then be shipped directly to DeepGreen's land-based processing facilities, avoiding the need to construct costly haul roads, rail lines and site infrastructure commonly required for land-based mining operations. DeepGreen plans to use its patented process to extract the manganese, nickel, copper, cobalt and zinc from the nodules. Unlike existing processing plants, DeepGreen's process is targeting zero waste production, meaning no tailings ponds. This represents a step change for the metals industry, where disposal of large volumes of toxic waste material in tailings ponds is considered one of the biggest environmental challenges facing the mining industry. DeepGreen and NORI are committed to stewardship responsibilities, as well as setting a new standard in managing environmental and social impact. To date, terrestrial mining operations have supported society's social and economic growth. But with declining ore grades on land, coupled with increasing environmental and social impacts, society must now look to a new source of economically viable metals that are produced in an environmentally sustainable way. Advancements in deep-sea technology over the past 40 years means the time has now come to unlock the value of mineral resources in the 70% of the planet that is covered with water. DeepGreen is positioned at the forefront of this revolutionary opportunity.